Greetings. This is a reaction video. Basically, I'm going to comment a little bit on a video I saw from the Y Combinator group, which is in Stanford. And they were talking about the idea behind vibe coding, which is a term that had become popular just very recently. And it refers to the notion of, instead of using a generative pre-transformer AI to help you develop code, really kind of put it in the driver's seat and really point at it and really let it do its thing and go off and code things. And it is tempting to talk a lot about AI and how the hype, or what's hype and what's not hype is, and certainly try to go into that. But I will just say here that I'm very skeptical, having been in computer programming as long as I have. It seems that what AI does is mainly point out what we don't know and the complexities we don't understand about tasks that seem fairly simple, much less complex tasks like coding. Now, certainly this whole section of large language models is going to reveal some really new techniques for doing certain types of things. No question about that. The idea behind them has already had major impacts, for example, in structural biology and predicting protein structures. And so it's not that these type of tools will go away. It's just how they're going to be used may be very different than how people are hyping them up today. And certainly I would caution anybody for trying to go in, and if they wanted to get into programming as a career, to kind of latch themselves on to the latest trend and only do that in the hopes that that will get you a job, much less a career, which will span multiple jobs. In this current economy, you'll not be working for one company for as long as you might want to. And you have to be flexible and be able to move from one place to another to further your career and your career goals as you see fit. The thing about it is what caught me is the irony is that how many people on that video, or how many people that work at the Y Combinator, or the people that they work with, even know why it was called what it is in the first place. And certainly, if you do the search for Y Combinator, you'll find more information at first about this, indeed, startup funding group than the bit of functional programming that describes the Y Combinator as how one can define the notion of recursion in a purely functional way without discussing things like stack and so forth. And how if you had something that was merely a higher order functional language like the lambda calculus, that you can do it indeed to write recursive functions. And here it is. This is what's called the applicative order Y Combinator. And that itself, why it's called applicative, and I'll put this in comments here, is that this is a version of the Y Combinator that works with languages that use applicative function application, which what that means is that when you call a function and give it arguments, those arguments, which of course in a purely functional world will also be functions, those are actually evaluated before they're passed into a function. Whereas normal order for functional programming languages do not evaluate the values of a parameter to a function until it is absolutely needed. So they are basically lazily evaluated, as some people call them. Basically, these expressions in a function are only called until the last possible moment, whereas other languages like Scheme I'm using here is an eager language. And what it'll do is it'll try to evaluate the value of that parameter right away. Now, so what this does is that literally, basically what we'll do is that what this will do is we'll return a function. That's why the first thing I'm doing is I'm have a function here that takes the one thing that's called f. And what it'll do is this f, whenever you need it, will call this again. It will expand itself and replace itself over and over and over again until you no longer call it. And this is exactly what this is doing. And boy, there's a lot of theory behind it. And I certainly wouldn't expect anybody that was just a random programmer to understand this. And not only that, but I expect fewer and fewer people that are even graduate students to be even exposed to this idea. I just found it very interesting that a company that is named after a very deep concept in functional programming languages put out a video saying, hey, why not just let the AI drive, man? Just go with the vibes, let it do its thing. And is that the newest type of coding? And is it really a good thing that we could just point it one direction or the other? Basically, hey, this is three people in the Y Combinator saying this. And again, the irony just was a little bit too much for me to handle. Basically, you've named yourself after a very, very deep part of computer science, and then you go off and saying it's like, well, don't worry about actually learning anything about the field we're talking about. Ride this AI bubble towards this next new way of coding, and ignore the fact that we just have to have a lot of money invested in this, and we have to have this work, or we're out quite a few bucks. And as a junior programmer right now, looking at the fact that people are crunching down, there's fewer hires going on. There is not the festive hiring that was going on during the pandemic. And not only that, but the idea of people proactively hiring talent to prevent other companies from having that. Those days are probably gone for the next few years, if not forever. It becomes the question, well, what do I do? And it's very easy for you as a junior programmer to tie yourself to what this next AI trend is and not knowing where it's going to go. And I only caution you that I've seen that become, for every time that it's a career path that works out for people, more times than not, it is actually an anchor that drags them down and allows them not to advance. Because something else does come along. Something else does change the industry, and you have to adapt. And if you don't have that flexibility and get tied to this one idea, even one that is as powerful as a generative pre-transformer long language model, that can be really detrimental for you having a career versus a series of jobs that become increasingly less and less fulfilling. So what I'm going to argue is that what you can do as a junior developer is do things the hard way. Learn things the hard way. Now, the problem behind this is that not everything that is hard is actually useful. Some things would just be grunt work. You can do something 1,000 times, and if you haven't learned if you haven't learned anything new about how you do it the 1,001 time versus when you did it 100 times, then that's just rote work. That is hard. That is really hard, and sometimes that's what you have to do as a job. But that's not the same as deliberately practicing, as trying to get better or to gain further understanding. And what I will argue is that to get deeper understanding, especially in computer science, you have to do some very unintuitive types of things. For example, I've done a whole series on the Racket programming language, which is right here, which is a superset of Scheme. And I am trying to make the argument that this is actually an excellent thing to study if you're interested in more about how programming languages work and the internals of them. But the thing about it is that I fully recognize that you may never write Racket or Scheme code ever in your career. And that is actually going to be the case for almost everybody. The amount of people that use this language is very, very small. But that doesn't change the fact that it is incredibly useful from an educational standpoint. Not only that, but I actually think it's a very enjoyable type of environment to program in. But it's very easy to say that, oh, well, if I don't use it in my real world career, it's not going to be useful. But the thing about it is that certain things strip away a lot of what's necessary to get big things done, and that obscures the things you're trying to learn. And Scheme really strips down a programming language to its essence. It doesn't really have any syntax. As you can see, it's just parentheses. And as people called its predecessor Lisp, the acronym did not stand for list processing. It actually stood for lots of irritating, silly parentheses. But this simplification of this is the syntax, and that the fundamental data structure looks exactly like a program, that this list here also is just a bunch of atoms with parentheses in it, that allows us to do a lot of very interesting things and how to study programming languages in a very deep way. Also, what's interesting is that a lot of people are kind of using what I would call a poor man's version of Scheme with confusing syntax. And it's one of the most popular programming languages out there right now. I'm talking about TypeScript and JavaScript. And if you look at the history of JavaScript, it's very clear from the creator himself saying that he actually kind of used Scheme to inspire what he was doing for the JavaScript language, but instead of using this parentheses type of, syntax and all this kind of stuff, that he was inspired because of how popular Java was to use a Java-like syntax, but really kind of use these simple ideas underneath that. Well, it doesn't really work for lots of complicated reasons. There's lots of limitations there, but I won't blame the person that was doing this as part of a demo for a browser way back in the 90s to not have the insight into, this is going to be used 40 years later in all sorts of places that no one ever dreamed about. But at the same time, it's one of those things where I would go and say, well, there is value in looking at what inspired it and what it does well that TypeScript and JavaScript does not do well and does obscure. And it will actually make you a better TypeScript programmer, JavaScript programmer, or programmer in another language entirely. And not only that, but no language lasts forever. And that seemed to have not been true. I would say that basically the C guys for the longest time have said that they were going to have C around for quite some time. And I would agree. I would have thought that C would never not have a place where people were not only maintaining C code bases, which I think will happen for a very long time, but there wouldn't be a demand for people writing new C or C++. And certainly given the rise of Rust and Zig, I actually am at a point where I can say with some certainty that there might be a future that C is not nearly as popular or as used in the embedded space or the operating system space as it was. And considering how completely dominant C is in that space, that's a big statement. So, but does that devalue learning C as a programming language? Absolutely not. You'd have a hard time understanding why Rust exists without understanding some of the limitations that C and C++ impose on a programmer, what that performance trades off in terms of safety. It's basically, if you don't understand why pointers have problems, it's really hard to understand why the borrow checker in Rust is a thing, or why Zig does certain things were differently than just C, for example. So, and certainly in my career, that's been true. I mean, I've had to learn more languages than I could count before I finally got to where I am. It was one of those things where I started out programming BASIC on an Atari, and before you knew it, I had to learn Pascal, and then I learned C, and then C++, then I learned Java, and then I learned C#, and then I learned all sorts of languages in my graduate career, from ML, Haskell, OldCaml, that whole family, for when I was doing some research, and so on and so forth. And there's been things that exploded out of nowhere that I thought never would happen. When Java first came out, all these researchers around me nodded very sagely that, well, this was very nice, but we all know what happens to garbage collection languages. No one really uses them because the performance isn't there. Well, we were right until Java proved us wrong. And now that garbage collection is a mainstream type of thing that's used in all sorts of places. Same thing with Python. People had didn't really understand why we needed yet another scripting language until we understood how well Python can glue other libraries together. And of course, now Python is one of the fundamental programming languages that people teach classes in. So you never know what the future is going to be in. However, there is a big advantage to being able to understand, these languages are all variations on the underlying idea of a programming language and what a programming language is. And learning things, what the difference between imperative and functional style is. Functional versus object-oriented. If you want to get really fancy, lazy versus eager functional programming, and so on. That will make things much easier for you to do when you realize that sometimes the syntax is just another way of doing some of the same ideas. Not only that, but it'll help you point out, this is what this language does that's very interesting, that's different. This is kind of what's the same old. And it really sets you up for a lifelong ability to learn new programming concepts and ideas, and to be able to roll with the punches when it comes to, I got to go write this now in, we're changing some stuff in TypeScript 7. We want you to use this now, or this is this latest thing in React. You can start to roll with that a little bit better because you understand the fundamentals are still there. So again, I don't want to discount to all you junior developers out there how difficult things are. I have been very fortunate in my career that I got into the space fairly early. But I must understand, I also understand and sympathize with people there, because I too was a part of a very big layoff when I was at HP, and it's a horrifying experience, and no one should have to go through it. And again, I hope that this cycle of companies just hiring and firing, you know, they do a little bit better, and really do much better, in fact, in hiring talent and nurturing talent, not just to get rid of them when the stock doesn't quite do well one quarter. And I certainly hope that's the case. For all those of you out there that are still looking for jobs, just hang in there. It's really difficult. For any senior programmers that might be watching, you know, have a little bit of have a little bit of empathy for juniors. We were all juniors once. But two, also embrace this notion that things change, and don't necessarily be resistant to them, but also open up yourself to really being a better mentor to juniors. I frankly see a lot of seniors out there that are nothing more than surface experts that are trying to compete with their juniors out of some fear that since they're no longer able to code 80 hours a week and have to do things like sleep and eat, excuse me, that they have to actually basically go after any competition with a ruthless amount of tactics and trying to basically squish them versus actually making them better. The best programmer out there will be one that has 10 programmers that end up being better than him in an organization. That's just how I see things. It's better to have taught 10 than to ruin one. So yeah, have a little bit of empathy about that. I'm certainly, there's going to be some of you in the comments maybe disagree with me on this kind of stuff, and that's certainly fine. This is just my opinion. This is not really kind of this is a fact, but I do think it's kind of interesting, again, to see how this discussion around AI has really kind of taken people away from the underlying fundamentals and craft of programming and turned it into this kind of game in which you trade English with a large language model and hope something useful pops out of it. Anyway, thanks for watching this video, and hope to see you in the next one.